Okay, today's lesson we're going to learn about solving exponential equations. So there are a couple of techniques that we're going to learn in order to solve exponential equations. We're going to focus on three main types. The first type is when you have a single exponential expression. And how do you solve that? The second type is if you have two exponential expressions that can be written at the same base, or if you have two exponential equations that cannot be written with the same base. And so for our first technique, we're going to solve exponential equations that have only one exponential term. This is a three-step procedure. The first step you're going to do is isolate the exponential term. So that means I need to get the a to the x term all by itself. So everything else, if I'm multiplying, adding, or subtracting anything to a to the x, I need to move it to the other side of the equation. Once I've isolated the exponential term, our second step is to change to logarithm form. So remember last class we learned how to change in between logarithmic form and exponential form. So we're going to rewrite the exponential term as a logarithm. You can choose to either use the common log or the natural log, whichever form that you want. I'm sorry, that's in the next one. Then we're going to solve for x using any type of technique that we've learned. You will need calculators for this section. All right, so let's look at example 1a. We have the equation 2 to the x equals 7. So I notice I have one exponential term, 2 to the x. So I need to isolate that exponential term. It's already isolated because the number raised to a power is by itself. So I'm just going to convert this to a logarithm equation by writing log base 2 of 7 equals x, and then solve for x. Well, I already have x by itself, but in order to figure out the exact value, I need to use the change of base formula that we learned previously. So I'm going to rewrite log base 2 of 7 as the natural log of 7 divided by natural log of 2. Now you can choose either the natural log or the common log here. You'll get the same answer. Then I'm going to write my answer. So my answer is x is approximately 2.8074. For our purposes in this class, if it doesn't specify in the directions what to round to 4 decimal places. All right, instead of doing your B, I'm going to do C. So I want to do one more before I have you do your own. So this time I need to isolate my exponential term e to the 0.6x power. So I'm going to start by subtracting 20 from each side. So 240 minus 20 is 220. I still don't have the exponential term by itself because I'm timesing by 40. So I needed to divide each side by 40. And now I have e to the 0.6x is equal to 11 over 2. And now I've isolated the exponential term. So I've done step 1. Once you've isolated the exponential term, now I need to convert this to the log form. So that's going to be the natural log of 11 halves is equal to 0.6x. Then I'm going to solve for the x by dividing each side by 0.6. At this point, I'm going to go to my calculator, plug this in, and estimate my answer to 4 decimal places, which will be 2.8412. Okay, now I want you to pause and solve this problem B. Okay, the first thing I need to do is isolate my exponential term. So I'm going to add 1 to each side to get 3 to the x plus 2 on the side by itself. Then I'm going to convert this to a logarithm, and so that'd be the log base 3 of 8 is equal to x plus 2. Then I need to solve this equation by subtracting 2 from each side. Now be careful. You can't take 8 minus 2 and get 6 because 8 is inside the logarithm and that 2 is outside, so you cannot combine these. This is as simplified I can do. The only thing I need to do now is change the logarithm expression using the change of base formula. Again, you can use common log or natural log, and then plug it into my calculator. You should have got negative 0.1072 as your answer. So that's our first technique of solving exponential equations when we have a single exponential term. Now we're going to learn our second technique, and this is when you are given two exponential terms. Two terms, a number raised to a power twice. Well, power, that's a variable. There's two separate cases here. The first case we're going to look at is if they have the same base, if the two exponential terms have the same base or can be made to be the same base. Then the first thing you're going to do is you're going to rewrite each exponential term so that they have the same base. So we're going to rewrite the equation to make the bases the same. Once you've done that, we're going to use what's called the one-to-one property and to set our exponents equal to each other. Because remember, a to the x equals a to the y if and only if x equals y. So that's that one-to-one property we're going to use. Okay, and then we're going to use algebra to solve for x. So let's try a few of this technique. So notice in our example 2 here, we have 2 to the x plus 3, and then we have 8. 8's not the same base, but I can rewrite 8 as 2 cubed, so I can make it the same base. Now notice here I have 2 cubed raised to the x minus 1. Now when you take a power of a power, you multiply your exponents together. Don't forget to distribute that 3 to both terms, the x and the negative 1. Now I'm going to use the one-to-one property and set my exponents equal to each other. And now I have a simple linear equation I'm going to solve by isolating the x's. So how I'm going to get the x's how I'm going to solve this is I'm going to subtract x from each side. And now I'm going to add 3 to each side and then divide by 2. And I get x is equal to 3. Okay, I want you to try the next example. Okay, in this example, you have 2 exponential terms, but they don't have the same base, but I can rewrite 25 as 5 squared. Still don't have quite the same base, but then I remember my rule that 1 over 5 squared is the same as 5 to the negative 2 power. Now I have the same basis. So I'm going to do my distributive power of a power, and that's going to give us 5 to the negative 4x minus 6 is equal to 5 to the x minus 5. Then I can use the one-to-one property and set each of these exponents equal to each other. Solving for x by adding 4x to each side, and then adding 5 to each side, I end up that x is equal to negative 1/5 in this problem. Okay, our last technique for solving exponential equations is when we have more than one exponential term, but they do not have the same base, and you cannot write them to have the same base. This one has 5 steps. The first step you're going to do is you're going to take the log or the natural log of both sides, the common log or the natural log of both sides. This is often referred to as hit it with a log. So we're going to take the log of each side. Then we're going to use our properties that we've learned in the previous sections of logarithms. And we're going to use that more specifically, we're going to use that power property of logarithms, and we're going to bring down the exponent. And the reason why we do this is we can't solve for x while it's in the exponent. We can only solve for x when it's on the main line of the equation. Then our next goal is we're going to use all the algebraic steps that we know to get all the terms with x on one side of the equation by itself. So you'll often have parentheses, you'll have to do your distributive property, then you're going to need to get all your x terms on one side, all your terms without x on the other side. So this is going to take a lot of the algebraic steps. Okay, and then we're going to solve for x. Now, you'll often have to do factoring. You'll often have quadratics that you'll have to factoring out your GCF. There's many techniques that we've learned in algebra. So you're going to use all your algebraic techniques in order to solve for x. And then, so once you factor out your x, now you have x by itself, so you can solve for the x. So that's kind of the procedure that we're going to do on when we have 2 exponential expressions with the bases are different and cannot be made to be the same. So here's an example. We have 2 to the x is equal to 3 to the x minus 1. So 2 and 3 are not the same base and cannot be made to meet the same base. So first thing I'm going to do is hit it with a log. So that becomes the natural log of 2 to the x is equal to natural log of 3 to the x minus 1. This is what that step of hit it with a log means. Then I'm going to use my power property, and since my power of that first logarithm is x, I'm going to move that to the front and rewrite it as x times the natural log of 2. And then the second, that's going to be equal to x minus 1 quantity times the natural log of 3. Now I need to get rid of the parentheses, so I'm going to use my distributive property on the right-hand side and to write that as x natural log of 3 minus the natural log of 3. Now, all the terms that have x need to be moved to one side of the equation. So I'm going to subtract x natural log of 3 from each side. Then that gives me I can factor out my GCF of x on that left-hand side, and that leaves me with the natural log of 2 minus natural log of 3. And then dividing each side by the natural log of 2 minus natural log of 3, I end up that x is equal to negative the natural log of 3 divided by natural log of 2 minus natural log of 3. Then I'm just going to punch this into my calculator to get my 4 decimal answer, which will be 2.7095. So to review, I hit it with a log to get our logarithm term. Then I use my power property to move the x's to the front. Once I do that, I needed to use my algebraic techniques to get our x's, to get rid of all parentheses. In this case, we did the distributive property. Then we're going to move all the x's to one side of the equation using our algebraic techniques. And after that, all we're going to do is we're going to use some algebraic techniques that we've learned in previous classes to solve for the x. And so those are our basic steps. Okay, now it's your turn. I want you to try this next problem. Okay, I have two exponential terms. I do not have the same base, so I'm going to hit it with a log. Last time I hit it with the natural log, so I'm going to hit it with the common log. You can choose whichever one you want. It's just a personal preference. Next, I'm going to use my power property to move x minus 2 to the front, so that's going to be times log base 5, and I'm going to move 2x plus 3 to the front and multiply it by log base 4. To get rid of the parentheses, I'm going to distribute log 5 to each term on the left, so that becomes x log 5 minus 2 log 5. Now I'm going to distribute log 4, get 2x log 4 plus 3 times log 4. Then once I do this, I need to get all the terms that have x onto the left-hand side. So I'm going to subtract 2x log 4 from each side. And then move all terms that don't have x onto the other side. So I'm going to add 2 log 5. Now I can factor out my GCF of x on the left-hand side. And divide each side by log base 5 minus 2 log base 4 to get x is equal to 3 log 4 minus 2 log 5 divided by log 5 minus 2 log 4. Then I can just punch that into my calculator and get my 4 decimal answer, which is negative 6.3429. Now I want to show you another way that I can do this. And this is depending on if you had problems typing this into your calculator, because that's a lot to type in. So once I get to this step when I'm isolating my x term, you can use the properties of logarithms to condense these logarithms into single expressions, and so it's easier for you to punch it into your calculator. So what I could do here is so notice that I took the number in front of the logarithm inside using my power property. Now remember, subtraction becomes division. And on the right-hand side, I also moved my numbers and to make them as exponents, and then addition becomes multiplication. So it's just simplifying this down. I have x times log of 5 over 16 is equal to log, and then 4 cubed times 5 squared gives us 1,600. Then dividing each side by log base 6 to the 16. And then I punch this into my calculator and I get the exact same answer. So notice it just depends on how familiar or how comfortable you are with the exponential rules, the properties of logarithms, and how effective you are with your calculator. So whichever technique you use is fine with me. So try your favorite technique for this next example. Okay, I'm going to start by hitting with the log. I'm going to choose the natural log. Then I'm going to use my power property and write 2x minus 1 times the natural log of 4 is equal to x plus 5 all times by the natural log of 3. Use the distributive property to get rid of my parentheses on the left and right hand side. Now I'm going to move all the terms with x onto the left hand side, so that's going to be 2x natural log of 4 minus x natural log of 3 is equal to 5 natural log of 3 plus natural log of 4. On the left-hand side, I have a GCF of x, so I'm going to factor that out. I'm going to choose to solve this using my properties of logarithms. So I notice I have 2 times natural log of 4, so it becomes the natural log of 4 squared. And on the right-hand side, I have 5 times the natural log of 3, which becomes the natural log of 3 to the 5th. Then subtraction becomes division, so this becomes log of 16 divided by 3. And then addition becomes multiplication, so I need to take 3 to the 5th and times it by 4. When I take 3 to the 5th times by 4, I get 972. And then x is equal to log of 972 divided by log of 16 over 3. Now notice I do not change division to subtraction. Remember, that goes the other direction. So this number is what you have to type into your calculator. And rounding to 4 decimal places, I get 4.1096 when I plug this into my calculator. Now, you did not have to simplify it that far with your properties. It just depends on how effective you are using your calculator. So those are the techniques that we know how to solve exponential equations.